Hey guys, we're up to 9G, which is Eulerian trails and circuits. So we've looked at trails and circuits in the previous lesson, but these Eulerian ones are sort of a little bit special. So it explains what they are just here. So a Eulerian trail is a trail that includes every edge in a graph, um, and because it's a trail, we can reuse vertices. Um, so we're going to see if we can find a Eulerian trail out of this network or this graph here. Now, before we do it, let's just have a look at this little point here. So it says if the graph has two odd degrees, the trail must start at one of the odd vertices and end at the other. So before we start this, let's maybe have a look and see what degree all these vertices are. So hopefully you remember, degree is how many edges connect to each vertex. Or vertex. So here we can see we've got two. This one has three. This one has two. 2, 3, and 2. All right, now let's just see here. We've got a couple that are odd. So again, if the graph has two odd degrees, then the trail must start at one of the odd vertices and end at the other. Okay, so we're going to have to start either here or here. Let's maybe just start here. So remember, a Eulerian trail means we just need to touch each of these edges. So let's start here, go to here, down here. Alright, so I've done a little bit of a lap here, but I haven't touched one of the edges, which is this one here. Now, I'm back to this vertex, which I've used before, but that's okay, because you're allowed to reuse vertexes, and we'll finish off here. So we started here, and we finished here. So this one works. This one does have Eulerian trail. Now, I just want to label the path that I've used. So I started at B, then I went to C, then I went to D, then I went to E, then F, then A, then B, and then I finished off down at E. So this bit here shows the path that I took. Alright, so that's a trail. With trails, it doesn't matter if you start or finish at different spots, that's totally fine. But we're going to move down to Eulerian circuits here. Now, hopefully remember that with a circuit, you have to start and finish at the exact same spot. All right, now let's just read through this stuff to make sure we're nice and clear. So for a Eulerian circuit, it's a circuit that includes every edge in a graph. And again, we can reuse those vertices. Now, a graph must have all even degrees for there to be a Eulerian circuit. Now, what I can see here is that most of them are even, except we've got a couple of odd ones here and here. So I meant to put another edge in there before, so I'll put that in there now. Now, looks like they're all even, but I'm just going to check. So A has 2, this one has 4, this one has 4, 4 as well, another 4 here, and another 4 here. So we can see that they're all odd. Now it's important that we check that beforehand. It's important that we check that beforehand because if any of them are odd, it means it's not going to work. So why would we try to find a circuit if we know there's not going to be one? All right, so let's make a start. I might start here at A. Go this way. I might do a little bit of a lap around the whole thing to start with. Alright, now I'm not going to go to there because I wouldn't have used all the edges just yet. So I might go over to the middle here. Okay, now I've used those edges. Back up here. So you might notice that I'm reusing vertices. It does not matter as long as I touch all the edges and then finish off just there. So there we go. So that was a Eulerian circuit because I've used every single one of those edges. Now I just want to be clear about the path that I've used, so I'm going to write down those letters again. So I started at A, then went to B, then C, then D, then E, then F, then D, I went back to C, then F, then B, then I went to E, and then finish back at A. Alright, so there we go. That's how you do Eulerian trails and circuits as well.